Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be doing another question for the grade 11. But before we move on, do not forget to subscribe for the channel and thumb up so you can get all the notifications and videos I post on regular basis. This time we're going to be doing a question on a redox reaction. I am going to leave the question in the description below so you can do it before starting, so you can only mark when watching the video. This one was question 9 in November 2023 in the Gauteng province in South Africa. The question says oxidation number make it easier to determine whether an element or substance is oxidized or reduced during a chemical reaction. Define oxidation in terms of oxidation number. That is the first question. And then oxidation is an increasing oxidation number. It's quite simple. However, remember that oxidation is the loss of electron, but this time they only one oxidation number. So oxidation is the loss of electron. I put it in that side. Actually, this one should move here. That is oxidation. Okay, so oxidation is the loss of electron in terms of electron transfer, and is the increase in the oxidation number in terms of oxidation number. Question 9.1.2, calculate the oxidation number of chromium in, and they give you an option there. Now, to do this one, you have to follow a certain number of rules. I'm going to leave all the rules in a description below so you can see, and you have to learn. It's no other way. You have to learn the rules, but not in terms of nobody will ask you to explain any rule, but they will ask you to calculate, like it is in this question, certain oxidation numbers, and you need to know the rule. So now let's have a look to this specific example here. What we have, this one that you have here, all this is what we call a polyatomic ion, and you can see that that polyatomic ion have a charge of -2. The charge of that polyatomic ion is -2. So the whole polyatomic ion will have an oxidation number, or let's say the addition of the oxidation number of every atom in there will be equal to the charge of that polyatomic ion. That is a rule. So if you add the oxidation number of chromium plus the oxidation number of oxygen, you will have that is equal to -2. So we're breaking this one. That is a rule. So let's, for instance, say the oxidation number of chromium times 2, because chromium, you have 2 of them, as you can see there, guys. So let's say 2 times the oxidation number of chromium plus oxygen, but oxygen, you have 7. Note once more that 2 negative is not for oxygen, but it's rather for the whole ion. Plus 7 times the oxidation number of oxygen is equal to -2. And let's go back, because that one may keep people confused. That 2 minus is for everything in the ion. It's not only for the oxygen. So this one is the first part to understand. That is a polyatomic ion. That 2 minus is for the whole ion, and then the rules say that if you add the oxidation number of every atom in the ion, you will have an oxidation number which is equal to the charge of that specific ion. Now, there is another rule that says that the oxidation number of oxygen is going to be always -2. The oxidation number of oxygen is always -2, except in a peroxide, which is not the case. As I said, I'm going to leave a link to a document with all the rules so you can follow the rules. So all we have to do is to substitute in here. Now we have the 2 times chromium, which is what we are looking for, plus 7 multiplied by -2 is equal to -2. Okay, so now why did I multiply by -2? Because the oxidation number of oxygen, as we can set, or we set here on this side, is always -2, except in a peroxide. This is not a peroxide. And this is mathematics. We have the 2Cr minus 14 is equal to -2. Correct? So you rearrange this one, you get that Cr is equal to -2 plus 14, no 17, 14. I say something and I write something else. I'm sorry, I'm a little bit dyslexic, you know. -2 plus 14 divided by 2. That is simple mathematics, guys. So Cr will have an oxidation number which is equal to positive 6. Now, note the following, because now some people will say, oh, I know, now I remember, all the time I have chromium will be negative 6, but it's not like that. If it was going to be always 6, then it will be in one of the rules. So it means it's going to change. It will change every time that chromium in is a different place, may be different. Now, doesn't mean that it's not going to be 6 many times. Many times chromium is going to be 6, but it will or it may change. So please do not memorize that one. Rather memorize the way of calculating. And not much, this one is 2 marks. They don't give marks for the way you're solving, they give marks for the final answer. Okay, so I hope that one is quite clear. Let's continue. The question 6.2 says, consider the unbalanced equation below. And they give you that equation Fe2 plus Cl gas plus Fe3 plus Cl negative. Give a reason why the reaction above is a redox reaction. And let's speak a little bit about redox right here at the bottom. Now, redox is a word that is divided in 2 parts. The first part is re, which comes from reduction. Re will come for reduction. And ox is coming for oxidation. So if we divide, redox reaction is a reaction where a reduction and oxidation take place. Both of them will have a transfer of electron. How do I know that there is a transfer of electron? Because there is a change in the oxidation number. This is a little bit for you to know why is this reaction a redox reaction. If you notice that and you go for instance to iron, from reactants to products, you can see that there is a change in oxidation number from positive 2 to positive 3. And if you go to chlorine, you can also see there is a change in the oxidation number. Let me just fix that a little bit, a line there. There is a change in the oxidation from 0 to -1. So that was a question for a 9.2.1. What is that? Because there is electron transfer. It is a redox reaction because electrons are transferred during that chemical reaction. Identify the formula of the reducing agent and explain the answer in terms of oxidation number. So what is reducing agent? Well, reducing agent is that substance that causes another to be reduced, but itself undergoes oxidation. Okay, so that is important to notice here. So we're looking for the substance that is going to be oxidized during this chemical reaction. So let's rewrite the equation here and let's see what happened to each of them. So Fe is going from an oxidation number of 2 plus. The first thing we're supposed to do before this one is to identify the oxidation number. So let's do that one in the right way. So let's move it a little bit down and let's write the oxidation numbers on top. For Fe2 plus, this is a monoatomic ion. According to the rule, the oxidation number will be the equal to the charge of the ion. So the oxidation number here is positive 2. The second one is a molecule of only one type of atom. According to the rule, that one will have an oxidation number of 0. This one is 3 or positive 3, and the last one is a -1. That is the oxidation number of each of those different atoms or ions that are involved in the specific reaction of this reaction. So let's first look at ion. What happened to ion from reactants to products? The oxidation number increases from positive 2 to positive 3. It means it does lose 1 electron. So this one is oxidation. That one is oxidation. So ion is being oxidized and therefore is the reducing agent. So we identified the reducing agent. They say explain your answer in terms of oxidation number. Why? Because the oxidation number increases. All right, so you can write here the oxidation number. Hey, I wrote D in Spanish. The oxidation number increases. There we go. And that is the answer. From, if you want, from positive 2 to positive 3. Now, let's look at the other one. They didn't ask, but we are going to look. Chlorine. What happened to chlorine? The oxidation number is grown from 0 to -1. So it decreases. It means this is reduction. So reduction because the oxidation number increases. We say that chlorine is being reduced. Therefore, chlorine, I'm going to write it Cl2, that is not an L. Cl2 is the oxidizing agent. The oxidizing agent. Guys, we are almost done. The next question here says write down the reduction have reaction. So we're going for reduction, and let's write this one. We need to write both of them in order for us to balance the question. So let's do both of them, and therefore this is going to be questions 9.2.3 and 9.2.4, both of them. So let's write the half reaction for each of them. Now guys, note something. There is a table like this one that you get all the information. However, the purpose of grade 11 is not to use the table, but be able to do it without a table. Maybe I'll make another video regarding that table, but let's do it without a table, because the idea is that you are able to do it without a table. So let's go for the reduction, because that is the question, and then we're going to do oxidation. Reduction. What do you have on the left-hand side? Cl2, and then it's going to Cl minus. So for reduction, let's write it here. Reduction have reaction. So we have Cl, that is 0, Cl2, and that is going to Cl minus. Note, all I did was writing what I have on the left and what I have on the right, without the oxidation number that is already in this equation here. So now we have to balance the atoms. We have 2 chlorine, we have 1 chlorine, so we have to add a 2 at the front, and that was the first step. We have now the number of atoms balanced. Now we have to balance the charge. So, and we're going to balance the charge by adding electrons to the more positive charge. So let's look at the charge. This one here have a charge of 0. We saw it already here. It have a charge of 0. This one here, and this is often a mistake, we have a charge of negative, but it's -1 times 2 because it's at the front. You can see there. So the charge here is -2. All right? A 2 at the front with a -1 that gives me a charge of -2. We have to balance. We're going to add electrons to the more positive charge. Remember, it doesn't mean that it must be 0. It must be balanced, equal. So we have to add electrons to the left-hand side. How many? Well, if the charge must be -2 and I have a 0, if I calculate, this is simple math, I must add 2 electrons. So from here, what will I have? I'll have Cl2 plus 2 electrons. That will give me 2 Cl minus. This one is the reduction have reaction. The table, as I say, may be used. Don't misunderstand what I mean. The thing is, you're supposed to be able to do it without the table. That is the reduction have reaction. Let's do it for the oxidation. It's not part of the question, but we need it in the time we are going to balance the question. So in the oxidation have reaction, what we have? We're going to do the same. On the left side we have Fe2 plus, and on the right side we have Fe3 plus. So we have here Fe2 plus, and on the other side I have Fe3 plus. We are going to follow the same steps. Balance the atoms, which in this case they are already balanced. So now in step 2 we're going to balance the charge. And to do this one, let's determine the charge. On this side the charge is, that is the oxidation number. So remember, we are working now with the oxidation number. There we go. So on that side is +2, on the right side is +3. So we come here, we have a +2, and we come here and we have a +3. We are going to add electrons, right, to the more positive side. We're going to add electrons to the more positive side, which is the right hand side. How many electrons I can add so both of them will have the same charge? Well, only 1. If I add 1 electron here, that +3 minus 1, because electron is -1, will give me +2. So that is what we have now already with the electrons balance. So we come here and then the balance oxidation, this is oxidation half reaction, is going to be Fe 2 plus arrow Fe 3 plus 1 electron that we add there. This one is the oxidation half reaction. It was not part of the question, but we need it for the balancing. Alright, so that was all. It's quite simple to write the half reactions. Remember, once more, they are all in this table. So I'm sure your teacher maybe go through the table, but you need to know how to write the tables. If you look carefully here, let me see if I can find it. We have ion there. It is one of the ions, and then the other one was chlorine, isn't it? I think chlorine is supposed to be at the bottom of this one. There is chlorine here. Okay, there is no, it's not that one. It's not that one. I'm looking for chlorine. There's also many chlorines here. It's here, this one here. So, but you must be able to write this one. The idea is for you to learn how to do it, okay? So now, to balance the chemical equation is not difficult also. To balance the net reaction, we need both half reaction as we have them here. So all we're going to do is to rewrite the half reactions here. Here we are. Here we are the two half reaction as we did before. It's nothing new. Now what we are going to do, we are going to make sure we make the number of electrons the same. So we do this one like if it was mathematics. In the first side, or the first half reaction, we have 2 electrons. In the second, we have 1 electron. They must be the same. How can I do that? I can multiply the second equation, the whole equation, times 2, and then they will have the same number of electrons. So if I have that one, now I need a new page, and I think I went too far down. So if I have that one, I'm going to do it here. I'll have Cl2 plus 2 electrons. I didn't touch that equation. 2Cl minus. All right. In the second one will be 2 Fe2 plus, an arrow, 2 Fe3 plus 2 electrons. Now the electrons are the same. All you're going to do, like in mathematics, is add the 2 equations, guys. So you have Cl2 plus 2 electrons plus 2 Fe2 plus everything on the left you add, then is the arrow. This arrow is going to be kind of equivalent to an equal sign, but remember they are not the equal things. 2Cl minus plus 2 Fe3 plus 2 electrons. I have electrons, the same number of electrons on both sides of the equation, so they will cancel each other, and then we are done. This one is the balance equation for that specific chemical reaction, the balance equation for that specific reaction, guys. Marking wise, here there is 1 mark for the reduction half reaction that they ask you. So there is 2 marks for writing the equation. If you have a double arrow, you won't get the mark. That's why I say you must learn how to do it. So you cannot have a double arrow that is not accepted. If you go to the table, all of them come with double arrows, as you can see there. You cannot write it like that. So there's 2 marks for that one. And in terms of the balancing, now they gave 1 mark for each half reaction. For each half reaction, as it is written, let's say here where I wrote it, here there is 1 mark for this half reaction, 1 mark for this half reaction, and then is a final mark for the balancing here. Okay, and well guys, this is all for now. I hope it helped. If it helped, thumb up, write comments, you can ask any question. Thank you for watching. I hope it helped. If it helped, thumb up. I'll see you next time. Mr. G here.